Hey guys, Mr. Bouchard here. I'm here to talk about contour maps today. I first want to start out with the example here. This is the Grand Canyon, right? And obviously the Colorado River runs through the middle of it. So obviously to map out things like this, we need special notation called contour lines, right? So we're going to learn the rules of contour lines, contour maps, and be able to read them today. Okay, so here's a picture of the canyon from space, right? So as you guys can see, you can only see from the shading, maybe the change in elevation, right? When I add contour lines though, you get more of an idea where the elevation is changing quicker, all right? So the more contour lines you see packed in an area, the steeper the slope. So you notice in the area where it's labeled canyon, you're gonna see all the lines are really packed close together. All right, and then when you get to the flat area, the plateau up here, you notice that they're further apart. Okay, so it's clearly shown on the map, that difference. Okay, so we're going to learn how to read maps like this, but not as packed with lines. These won't. This is a more difficult one to read, but we'll get to know the rules and get to know how to read these maps in general. Okay, so how are topographic maps used to interpret a landscape? All right, so first I want to talk about this here. So this is a map, and this is the side view or profile view. Okay, so with the maps, whenever you see closed circles or closed loops, you're going uphill. Okay, so you notice it says Able Hill and Baker Hill. All right, the closed loops are hills. So you head up this hill, 10, 20, 30, 40. Then you go back down 40, 30, and then down a little more, and then you go back uphill again, 40, 30, 40, 50, and then 40, 30, 20, 10. All right, so you can clearly see that in the profile as I described it. So you guys will have to do things like that with your maps and try to interpret them. So a topographic map or contour map is a model of the elevation field of the Earth's surface. Elevation is defined as height above sea level. So you may ask, what is sea level? Well, sea level is where the ocean touches the continent. Okay, so if you ever see the ocean on a diagram, that's always going to be the 0 foot or 0 meter contour line, depending on what units they're using. Also, contour lines are the lines that connect points to equal elevation. So if I walk on a contour line, I'm on the same elevation. If I walk across them, then I'm going up or down in elevation depending on which way I'm heading. So remember, closed loops indicate uphill, so you're going uphill as you go towards letter XB here. All right, contour interval is the difference in elevation between two contour lines. So in the case of this map, they tell you right down here, this is 20 meters. So here's 400. So XA is actually 380, right, because you're going downhill. And then you go up, 420, 440, 460, 480, 500, 520, 540, 560, 580 is the last contour line before you reach XB. Now, XB is going to be some number range here, all right, because it's in the middle of the hill. Okay, it's going to be greater than 580, all right, so the minimum value it could be is technically 581. All right, so you add 1 to this last contour that you see here, 580, and then you go up to potentially 1 less than the next contour line that would have been there. So add 20 to this, you get 600. 600 minus 1 will give you an answer of 599. So the maximum that hill could be is 599 feet. So if they ever ask you that to figure it out, all right, and the minimum it could be is 581. Okay, so that's the range that XB could fall between. If they ask you to estimate, pick a number safe in the range, and then you'll be good. All right, so you could say XB is approximately 585 feet or something like that. Okay, how are they created? All right, well, obviously a sea island is the easiest thing to think of when creating a contour map, because the outer part of it because it's touching the ocean, sea level is reached. So that's going to be 0 feet. Okay, so that first line is easy to draw, figuring out sea level, 0 feet. All right, when we decide to go up, what they do is they measure elevations at different points on each point of the island, either using obviously satellites now. In the past, they used to do something called surveying, seeing this change in slope of the land to be able to figure the elevation. But they would find those around the island and connect them up into equal field values, okay, until they get the whole picture of the island. So they started with a 20-foot contour interval, so first line is 20, and then they went up by 20, so this is 40, 60, and then 80, and then 100 when you reach the summit of the mountain. And P, once again, is falling in between the 100, so it's going to be one more than that contour line, so 101, 2 about one less than the highest next contour that would have been there, which is 119. Okay, so P is between 101 to 119 feet. Okay, now some other rules. In the middle of a volcano, we have something called depression contours, because in the center of a volcano, the elevation is going to decrease. Okay, so how do you note that on a contour map? So we have special contour lines called depression contour lines, which indicate a decrease in elevation. The first depression is going to have the same value as the last regular contour line if it's inside of a loop. I'll show you another rule in a moment in which that changes a little bit. All right, but right here, the 40 repeats 40 because this value right here, if you're picking this random point, could be like 42 or 43. Okay, and then you go back down to 40, and then if we had another one in here, then it would go down by the contour interval 20, and then if there was another one inside of that, then it would be 0. Okay, so basically it will follow the contour interval just like the regular contour lines. Okay, rivers are also another important rule with contour lines, because when the contour lines cross a river, they're going to make what's a V shape. Okay, the reason why they make a V shape, as you step down into a river, the elevation suddenly decreases, so the actual contour line will bend upstream to the higher elevation. Okay, so the way it works, the rule, how do you know which way the stream flows? So in this example, the bottom part of the V shape, right? So I'm talking the way it points upstream or opposite stream flow. Okay, so when you look at this example here, so here's your V shape. All right, and I'll show in a couple contour lines. That's the V shape is pointing that way, so that's upstream. So the river is going to flow this way, which ends up being high to low elevation. But looking at the contour lines alone, we can make this determination. All right, and sometimes on a map you have to do the compass direction, so I'll go over an example of that in a moment. Okay, profiles I mentioned briefly earlier on in the PowerPoint. Side view of the landscape, where the contour lines are closer together, there's a steeper slope. Okay, so if you look over here on this side, okay, you can see in the profile it also is very steep because the lines are closer together. Okay, on the opposite side, I'll move myself there. On the opposite side here, they're further apart, so this is more of a gentle incline, right? And you can see that clearly here in the profile, more of a gentle slope. Okay, so depression examples. So as I mentioned, so we'll repeat the last contour line. So this one's going down by 10, so 60, 50, 40. All right, so you can see when they go inside of each other, they start counting down by the contour interval. Okay, and the other example I want to show you, if you're between two contours and you have a depression, it's going to take on the lower value it's between. So in the case of 60 and 70, your depression's in between 60 and 70. 60 will be this value, because this point right here could be like 65. Okay, and then when you reach your depression contour, then you're at 60. Okay, then it will go down by the interval. So this is 10 again, so it's now 50. So just note on these two maps, different from the other ones which were 20 feet, this map is a 10-foot interval, both of them. All right, so I'm just writing that here for you. All right, but that's definitely the interval on that map. All right, lastly, stream flow with compass direction. Okay, usually on a map, north is going to be upward unless they note otherwise. So when you look at the map, remember, look for that V shape. So in the case of this river, the V shape is pointing north, but the river is flowing this way. So this river flows south. Okay, so this example, it's flowing south. Okay, Mill River on the other hand, the V shape is pointing this direction. So the river is pointing this way. If you do your little compass rose, okay, never eat soggy waffles. Okay, you'll know that this way is northeast. Okay, so this river in this case is flowing northeast. Right, because opposite the way the V shape points, it's pointing southwest, so the river flows northeast. Okay, and lastly, I want to talk about index contours. These are the dark index, the lines on the map that are sometimes labeled, and then the other ones they leave blank. All right, so if you ever have to find out the interval, subtract your two index contours. In the case of this one, 800 minus 700. And then you're going to divide by usually 5. Let's just confirm that. Okay, 1, 2, 3, 4, 5. So you don't count the line you're on, but count the second one after. 1, 2, 3, 4, 5. So there's 5 lines between, so that is correct. So it's going to be basically in this math problem, so 100 divided by 5, which is going to give you 20-foot contour interval. So it's not always 20. Okay, don't always take my word for it. A lot of times it is 10 or 20, but make sure you do the math, make sure you figure it out. I've had ones that go up by 50, 100, so just be careful and make sure you're counting correctly. All right, and I think that's it. So next time, I'll see you guys next time. Thanks for tuning in.